Okay, so let's go ahead and work this one out. It says rewrite each function to determine if it's an exponential growth or decay. Now, in order to do that, we need to kind of look at these two things, exponential growth and exponential decay. So let's scoot this over. This is decay, and this is growth. And you'll notice some observations quickly, that the growth one has to have a factor that's greater than 1 because it's 1 plus this rate, whatever it is. So whatever this is here, it needs to be greater than 1. And notice that the variable t, the exponent, is still left on the outside. So when it's asking us to rewrite it, we need something in here. We need the t on the outside, that's an exponent, and we need to see if it's greater than 1, if so it's growth, or if it's less than 1, and if so it's decay. So let's start off with this one right here. It says y equals, well, let's just work it out. So the first question we need to ask ourselves, if there's an exponent for fraction, is does it stay or should it go now, right? I mean, if there's ever a fraction, it's the first thing we need to ask, so we should ask.
So you got to let me know, should I stay or should I go? It's always taste.
So should it stay or should it go? So let's go ahead and rewrite this and see. So remember though, the ultimate goal is still to have that t on the outside, right? We still want that t there. So let's write this one out. It has y equals 100, but this is in parentheses. Now, if there's a denominator with an exponent, it goes down, right? So essentially, we're taking it to the 0.96 to the fourth power over 1, right? Or another way to look at it, which I think is much easier, is write it in exponential form. So let's do that since it's not that way. So radical form, right? Taking it to the fourth root, 0.964 to the fourth root. And so I like to pull out my scientific calculator at this time and let it do the thinking for me. Remember, you take a normal calculator, you turn it sideways to tilt it up, and then it turns into a scientific calculator. And I've shown the students already how to do this with Apple and Android devices. I happen to have an iPhone. So we'll take 0.964 and we'll take it to the fourth root. And we get 0.9908. So I would round that up to 0.99 just because it would be a little easier. So the answer would be y equals 100. And then we said 0.99 would be easier, to the t power. And now we can easily answer the question, is it decay or is it growth, by looking at it. So in this case, looking at the b here, is that a growth? Is that r plus 1? Or is that decay? Is that r minus 1? 1 minus r, I'm sorry. Well, it's obviously less than 1. If it is less than 1, 99 is less than 1, 0.99, so it's decay. So the answer to this would be decay. So decay, exponential decay. Alright, so let's try another one, see how we do. So here's one where the exponent is, there's t, but there's also a -3. Remember though, we're going to want that t to be there to answer the question. So the t would go to the 1.1, and so would the -3 exponent, right? They both would go to the 1.1. So if I were to rewrite it, part of it should go, the part that's going to the 1.1, the part should stay. So it looks something like y equals 1.1 over 1.1. The t is the part that stayed, right? And then parentheses, so you know the t symbol thing, and the part that went would be to the third power. And then what is 1.1 to the third power? Again, we'll get our calculator out, and we'll just type it in and turn it to a scientific calculator. 1.1 push the xy to the third power is 1.331. 1.331. So if we were to bring that in the numerator, it would be roughly 0.75 times 1.1 to the t. And since that's greater than 1, it would be a growth, exponential growth, right? I'll start growth. Good. Okay. I think we're starting to get this. So let's do a few more practice questions here. And I'm going to do some, and I want you to do some. So let me start off by doing one more, and then I'm going to give the students some. So we have y equals, notice there's no a here, there's just the b on this one. You remember the form is y equals a b to the t power, but we don't really have an a on the outside. Okay, so let's work this right out. Now the t's going to go to both, the exponents are going to go to both of these. I'm sorry. So like the t's going to go to 1 and the 2 is going to go also to the 0.9. We have y equals, so t times 0.9, well there's no reason, so we couldn't just leave that. But now we have this 2 also going to it, so 0.95 times itself, so 0.95 second power equals, well, approximately 0.9, roughly. So I'd put like y equals 0.9, and then since we solved that, it's no longer inside the parentheses there, it actually becomes our a, and 0.95 stays with the t, and so since it's less than 1, it would be exponential decay. This one's actually a much easier one because it's just a t. See if you can figure it out, if it's exponential growth or decay. Okay, so we have f of t equals 1.2 t, and well, 5 looks like it's just growth because you can see that it's already set up, and 0.2 is more than 1, so it's just growth. Not really any work to do on that. Okay. What about this one right here? What do you think? Okay, so let's work it out. And it's already kind of set up too, isn't it? On this one. But you can see that it's less than 1 by 0.08, because if you were to add those together, it would equal 1. So since it is less than 1, it has to be decay. Okay. Last one here. I can see my time is ticking, so I'm going to try to go quickly. On this one, the t would stay on the top, right? So it'd be f of t equals 3 times 1.02. You're going to want the t to stay on top. You're still going to want to do the 10th power and then multiply it by 3. So it's just 1.02 to the 10th power times it by 3 and leave the t on top. You should be able to